Hello Year 12, and here are the answers to your 5 a day. Let me know if you have any questions about those. So today we are going to be looking at combinations of transformations and how to find the rule of the image of a graph after some transformations. Now, as part of your holiday homework, you had to complete the first 3 exercises from this chapter, which were just about single transformations. But let's do a quick refresher on what doing different things to a function means with regard to transformations that happen to its graph. So if we have the function f of x and we add a to the x, what's the transformation that happens there? So hopefully you're saying to your screen, well, it's a horizontal translation of negative a units. Alternatively, you could say it's a translation of a units in the negative x direction. If we have f of x plus a outside the brackets, what do you think that does? So that's a vertical translation of a units, or a translation of a units in the positive y direction. So important words that you need to use are the type of transformation that's happening, which direction it's going in, okay, so now a few years ago I was told, oh, this one's wrong, hopefully you knew that's in the negative. So when stuff is happening to the x inside the brackets, it does the opposite from what it looks like. That's because I'm talking and writing at the same time. So a couple of years ago, I was told by some people who mark VCE papers that they would actually accept left, right, up and down, but I wouldn't recommend writing it because they might change their minds, whereas they can't argue with either of these descriptions. Okay, so other transformations we might see. We might have a scalar multiplying the x, so f of a times x. So when we multiply, you know that's a dilation. When it's happening to the x, it's the inverse of what it looks like. So here, instead of plus a, it was minus a in the negative x direction. Here, instead of multiplied by a, it's multiplied by 1 over a. And it's happening to the x's, so it's dilated out from the y-axis. So this word from is important here. If the a is multiplying the whole function, then that's a dilation of scale factor a from the x-axis. So we've got translations, we've got dilations, we also have reflections. Negative f of x is a reflection in the x-axis. It makes everything above the x-axis negative and everything below the x-axis positive. And f of negative x, a reflection in the y-axis. Okay, you need to know those and be very familiar with them. Now, I'll give you a moment to read this. Okay, read those transformations. Think about what that does to our rule. Now, the method I'm going to show you, which uses x and y dash, you will have seen before. If you're not particularly confident in getting the numbers the right way round, or the positives and negatives the right way round, this method is always going to be the same, will always work for you. So I recommend that you practice it plenty and become really familiar with it. So if we start with our coordinates x, y, the dilation of factor 3 from the x-axis happens to the y's, so the y's get multiplied by 3. Translation of 2 units in the positive direction of the x-axis and 3 in the negative direction of the y-axis. So our x moves 2 in the positive direction. Our y, it's already 3y, we're subtracting 3 from it. And then a reflection in the x-axis means the y gets multiplied by negative 1. Now, if we say let x dash y dash be the image of xy, that's what happens to xy after the transformations, then x dash is equal to what we ended up with here, y dash is equal to what we ended up with here. Now we can rearrange to make the x and the y the subject. This is why we have the dashes, so we don't get mixed up between which one's which. Then we take these expressions and substitute them into our y equals f of x. So instead of writing y, I've written 3 minus y dash over 3. Instead of writing x, I've written x minus 2. Then finally, I rearranged this to make y the subject, or y dash the subject, and then I forget about the dashes. And so this is the rule for the image after all of those transformations. Now, let's have a look at if this is what we expect. Dilation of factor 3 from the x-axis, that's 3 times the f of x. Translation of 2 units in the positive direction of the x-axis. Remember, what happens to the x is the opposite, so minus 2 to the x. 3 units in the negative direction of the y-axis. So at the moment, at this point, we're expecting this. No, we're not, minus 3. Negative direction of the y-axis. The reflection in the x-axis multiplies all of this by negative 1. So I get negative 3 f of x minus 2 plus 3. And then I've just written it with the positive 3 at the front because it's a bit neater. So go back through this example a few more times and use that to help you answer the questions in exercise 3D. There's only 4 questions for you to work through. Now, question 4 is actually quite a few questions. We've got 7 equations and we've got 6 sets of transformations to work with them. I will leave you to get on with that now. Let me know if you have any questions. Thank you.